Radical day 2 is very similar to radical day 1. The only difference is we just spent a whole section on the square root, which are looking for pairs or twos of something. We're also going to dabble in the cube root, so we're not looking for pairs of something, we are looking for triples. We might be dabbling in the fourth root, so instead of looking for 2 of things or 3 of things, we have to look for 4 of things. And I think the highest we go today is looking for 5s. So basically, so if you look down at problems 1, 2, 3, and 4, if there's no number on the outside, look at this one. This one has a 3 on the outside. This one has a 5. This one has a 4. If there's no number, it's understood as a 2. So basically, number 1 is a review from yesterday's notes. So let's review how to do the square root of 45. So the square root of 45 is made up of 9 times 5. The 9 can be reduced to 3 times 3, and the 5 drags down. So this is review to what you did yesterday. Again, we are looking for 2 of something. You're going to circle the 2 of something, and he gets to come out because there's a pair of them. So the 3 gets to come out, the 5 has to stay inside. And this is what you learned yesterday. You also learned yesterday, we might as well keep going here. We also learned yesterday 4 root 18. The 4 is already out there already from yesterday. And 18 is going to be 3 times 6. The 3 comes down. Some people think 6 is 3 and 3, but it's everything is multiplied on a prime factorization tree. So 6 is 2 times 3. The 4 is already outside. There is a pair of 3s. 1 3 gets to join the 4, which will make him a 12 out there. And notice that the only thing that's remaining inside that's not a pair is a 2. So this is what we learned yesterday. Now, what we're learning today is instead of a square root, we're going to do the cube root. Now, we're not looking for 2 of something. We are looking for 3 of something. So you're basically doing exactly the same thing as yesterday. You're going to make a prime factorization. 5 times 25 is 125. The 5 comes down and the 25 makes 5 and 5. I'm not circling pairs, I'm circling trios or 3s. I'm looking for 3 of something. So there is 3 5s, and for every 3 we circle, I can take 1 out. Notice that there are no lingering 5s, so the answer is 5. And then we're going to do the same thing for this one down here. The 4th root of 81. The 4th root of 81 is 9 times 9 is 81. The 9s make up a 3 and a 3 and a 3 and a 3. And this little 4 tells you that I need to look for 4 of the same thing. Instead of circling 2 or 3, I need to circle 4 of the same thing. And for every 4 I circle, I can take 1 out. And notice that there's nothing lingering in the problem. Same concept as the 5th root. 64 is made up of 8 times 8. 8 is made up of 2 times 4. 8 is made up of 2 times 4. Bring down my 2. My 4 is made up of 2 and 2. This is a 2. Boy, you have to be pretty neat. And I know you learned how to make these back in elementary school. You learned how to make a prime factorization tree. Kind of looks like a tree, doesn't it? As I expand it out. I'm looking for 5 of the same thing. 1, 2, 3, 4. So I'm going to circle 5 of them. Did you see that I circled 5? And for every 5 I circled, I can take out a 2. But notice now in this problem, there's a lingering 2, and he has to go back under. There's something wrong with this problem. Anybody see what's wrong with my problem? I took a 2 out, but there's a lingering 2. Right now this looks like a square root, but we are looking for 5 of the same thing. You got to remember to put a little 5 right there on the test, or it's going to be marked wrong. Okay, it looks like we're just going to do 3 more problems and we are done. These little roots kind of got pushed, but it's supposed to be that, and then this line's supposed to be here, and we'll get rid of this here. Okay, so here we go. We got 3 problems to go. Notice that there's already a 3 outside. It's already outside. We took the 3 and it's already outside. 432, I think I need a calculator to figure out what goes into 432, so 2 and 216, bring down the 2, 216 divided by 6 is 6 and 36, 2, 6, and a 6 and a 6, because 6 times 6 is 36. I can stop right now because I am looking for 3's of something, and I already got my 3's. I got enough 6's to take 1 out, but there's already outside a 3, and you're going to take a 6 out, so 3 times 6 is 18, and notice that there's a 2 left on the inside, but remember, that's going to be marked wrong. If you gotta make sure you put a little 3 inside of that rut. Make sure it's inside of the rut to show me that it's the cube root of 2. Okay, let's do this one. I'm going to rewrite it. It's 4 times the cube root of 128. So the first thing you're going to do is prime factor. 4 goes into there. 4 goes into 128 how many times? Let's see here. 32. This is going to be 2 and 2, and 32 is going to be 4 and 8. Bring down my 2 and 2, bring down my 4, 2 and 2, and my 8 is 2 and 4. Big tree, bring down my 2, 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 and my 4 is 2 and 2. If you're not neat and you don't keep bringing down and make the full tree, you're not going to get the right answer. So we have 2 problems left. Notice who's already outside. There is already a 4 outside. You're looking for 3's or trios, so you're going to be circling 3's. So I'm going to circle a group of 3, and I'm also going to circle a group of 3. So 4 is already out there, and I'm going to bring a group of 2 out and a group of 2 out. So 2 times 2 is 4, and 4 times 4 is 16. Again, how did I get that? There's already a 4 outside. I'm going to multiply it by 1 group of 2, and I'm also another group of 2. And 4 times 4 is 16. But I still have a little cube root. I still have a 2 lingering. There's not enough of them, so there has to be a lingering 2. Okay, last problem for your homework. Let's make him a -5 for once. Let's redo this one. Let's make it a -5. He's outside waiting, and 32 is made up of 4 times 8. 4 is made up of a 2 and a 2, and the 8 is made up of 2 times 4. Some people think 8 is a 4 and a 4. That's not multiplying an 8. And then the 2 comes down, the 2 comes down, the 2 comes down, and the 4 becomes a 2 and a 2. So that's called a factorization tree. We are looking for 4's. Circle 4 of a kind. Circle 4 of a kind. And for every 4 you circle, you can take 1 out. So I can take out a 2. There's a -5 on the outside already. So a -5 times 2 is a -10. Everybody see how I got a -10? A -5's already outside, and I can bring a 2 out to join the -10. But I still have underneath my 4th root, there's still a lingering 2 that has to stay inside. So this was very similar to day 1 radicals.